If you search for Joseph R. Miletta's U.S. Army Research Laboratory report, you'll find a title that looks like a leaked secret: Propagation of Electromagnetic Fields over Flat Earth. Look at this massive flat panel array mounted on a military truck. Engineers use Miletta's report as a practical instruction manual for aiming high-power microwaves. High-power microwaves, or HPMs, are directed energy weapons that deliver gigawatt-level bursts of radiation. These short pulses are designed to instantly fry enemy electronics. The engineering problem is that microwave energy does not travel like a solid bullet or a tight laser beam. It sprays outward, dragging along the ground and bouncing off the environment. Aiming this energy over real-world terrain introduces chaotic variables. Rolling hills, changing atmospheric pressure, and the actual curvature of the planet all scatter the signal. To mathematically guarantee a target is destroyed, engineers strip away those variables. They calculate the strike within an artificial universe where the Earth is perfectly flat. They start by building a half-space. A half-space is a geometric model that simplifies a complex 3D environment by treating everything below a mathematical plane as an infinite uniform solid. The universe is sliced perfectly in half at the coordinate z equals 0, with air above and lossy or absorbent ground below. Inside this simulation, the engineer suspends the antenna, acting as an invisible, steerable torch, at a specific height above this boundary line. When the weapon fires, the energy reaches the target through several routes. The first is the direct path, which travels in a straight line through the empty air. A second wave drops down and bounces off the flat ground like light hitting a mirror, reaching the target slightly later and with a shifted phase. Finally, a surface wave clings to the boundary itself, physically dragging along the dirt toward the target. The true destructive power delivered to the target is the complex mathematical sum of these three independent waves colliding at the exact same moment. When waves collide, they undergo wave interference. Depending on how their peaks and troughs align, they can stack together to double their power, or crash head-on, flattening each other out into complete calm. If the direct and reflected waves arrive out of sync, they cancel each other out. This destructive interference creates nulls, safe zones where the target survives the blast untouched. Engineers eliminate these safe zones by manipulating polarization. Polarization is the physical orientation of the antenna's electric field as it radiates outward. Orienting the antenna horizontally fails for near-ground targeting. The horizontal reflection produces deeper cancellation nulls and significantly weaker surface waves, allowing ground targets to escape damage. Vertical polarization solves this. A vertically oriented field generates magnetic loops that perfectly skim the surface. This configuration supports a strong surface wave that hits ground-level targets with extreme force. By physically twisting the antenna vertically and mapping the wave paths over a flat Earth model, military engineers align the invisible waves to maximize destruction. Firing gigawatts of microwave energy does not produce visible lightning bolts or glowing beams in the sky. To create a visible spark, the beam would have to hit the air breakdown threshold. The air breakdown threshold is the extreme power limit where an electric field rips electrons from neutral air molecules, turning the atmosphere into a glowing plasma. Weapon designers actively avoid hitting this threshold in the open atmosphere. Creating plasma prematurely absorbs the beam's energy, wasting power before it ever reaches the target. This same mathematics governs civilian technology. These flat ground interference patterns are the reason your global communications networks work. Look at these antenna panels on a cell tower. Cellular networks rely on these ground reflection patterns and polarization choices to position base stations. When your phone drops a call because you walked 3 steps to the left, you likely walked into a destructive interference null. Those everyday Wi-Fi and cellular dead spots are the same physical phenomenon engineers calculate when aiming a microwave weapon. The flat Earth in these documents is a vital mathematical fiction, the framework used to manipulate the invisible electromagnetic fields, shaping both directed energy warfare and the smartphone in your pocket.